So at 3, it's a jump. And remember, a jump does not have a limit. So the answer for C is D and E. But A and B, they have limits. There is a limit coming from the left and a limit coming from the right. So when you're looking at this discontinuity, or at 3, if you were to draw a dashed line at 3, on the left side of this wall, because this minus sign, this means from the left. That's what that little negative sign after the 3 means. And the plus sign means from the right. Okay, so now that we have that all squared away, what do you think your limit would be when you're looking at this wall? Where does this graph touch the wall on the left side? 1. So on the left side, the limit is 1. But on the right side, what's the limit? 0. Who had 1 0 in D and E? All right, good job. Look at letter D. What is the Y value at 3? That's what that's asking you. So it's a jump, but which one of these is the Y value? Which one is closed, the 1 or the 0? So the answer is 1. All right, go ahead and look at E and F. Try to do E and F. Now this one is a little tricky because at 4, we haven't done one like this one. But remember, if the graph stops, see how it stops here? There's nothing on the right side. So that would mean that we don't have a limit at 4. So at 4, it's D and E. So for question E, the answer is D and E. But F of 4 is 1. All right, what about the limit as x approaches 1? Do we have a discontinuity here? What kind of discontinuity do we have? Removable. Remember, removable is the only one that has a limit, though. So when you draw your wall, see how the left and right side are coming together at the same spot? We have a limit. So the limit would be what? What is that Y value? 5. Any questions about that so far?
Yeah, I got a question.
About which one?
The last one.
Sure.
Like I got 5.
Is it 5? Am I looking at it wrong?
4.
Wait, G?
Yeah, G.
So, hold on. This says the limit as x approaches 1. So, if you go across here, what's the Y value? 5. Yeah. I don't know why it's not writing on the board. That's weird. Okay, there we go. All right. Alrighty, so let's go ahead and look at, let's describe the end behavior of these graphs as a limit. So first of all, when you're writing the end behavior as a limit, the left side, you would say the limit as x approaches negative infinity. That's how you write your limit for the left. And on the right side, And actually, I forgot one thing. Let me add. It's the limit of f of x, g of x. Hold on one second. Let me make that. So we'll just say all of these are f of x. So we'll say f of x. So that's the left, because on the left side, x is negative. This left arrow, x is negative, because you have to look at the x-axis. So this means the left side limit. And then for your right side limit, you would say the limit of f of x equals, but instead of x approaching negative infinity, you would say x approaches what? All right. So real quickly, go ahead and write this 3 more times. Write this limit statement. All right, so these go pretty fast because, again, all you're doing is telling me what is the arrow doing. So for the first two, these two are odd functions, meaning that the highest exponent is an odd number, like x cubed, x to the 5th, x to the 7th, because the arrows are going opposite directions. So what's happening to the arrow on the left? Is it going, remember there's only 3 options. Either it's going up, down, or constant, straight out, horizontal. So what's happening for this one? On the left side, so here, let me go ahead and circle all of the left arrows. These are all of the left side arrows. And you're just telling me what they're doing. And I'm gonna circle the right side in a different color. And these are the right side arrows. Okay, so let's talk about the left side first. What's happening on the left side in this graph? Is it going up or down? So your limit, you would say, is it approaches negative infinity. But what is the right side doing? Going up, so it approaches positive infinity. Is that simple. Go ahead and do the next graph. So for the next graph, the left side is going up, so the left side is approaching positive infinity. The right side is approaching negative infinity. Now for the last two, because they're even, the left and right are the same. So I'll give you a minute to fill those in. So we got a positive infinity and a positive infinity for the third graph. And for the last graph, both sides are going down, so we have a negative infinity and a negative infinity. All right, any questions about that? All right, let's go ahead and finish this on out here, our packet. Now I want you all to take, let's see, use a pencil. This is your mini test. Take 5 minutes and see if you can answer. Is that what your graph looks like? That's your graph? Yep. Take 5 minutes, see if you can answer. Let me see. Yes. Oh, they're up there on that table. There's 2 handouts from yesterday. There's a packet and homework 12. I am so sorry. So we got, let me see, we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 questions. It shouldn't take you more than 30 seconds a piece because you're just looking at a graph. So I'm going to give you 5 minutes. Don't leave any of them blank. Take a guess. And if it's wrong, you just erase it. Who wants to volunteer what you put for A, B, and C? So this is all -1. So this is -1 from the left, -1 from the right, at -1, and f of -1. So what did you all put for A? Where is -1? -1 is right here. Is there any kind of discontinuity happening at -1? Yes or no? No. So they should all be the same. The left, the right is all the same. There's no discontinuity. So your first 4 answers should be all the same because at -1, we don't have any discontinuity. We don't have a jump, we don't have a removable, we don't have an infinite. So what is your y value at -1? So your first 3 answers should be -3. The first 4 answers. All right, so now let's move over to +1. Do we have something happening at +1? Is there some kind of discontinuity happening there? There's a jump. So from the left side of this red wall, where is this graph touching the wall on the left side? What is this value? What's this y value? -3. Wait a minute. Is it -3? Yeah, it is -3. You're right. Sorry. All right. What about the right side? This green graph. That's the right. What is the y value right here? 2. So because they're not coming together at the same spot, that means it's D and E for G, which means H. Which one am I going to use? Am I using a -3 or am I using +2? 2. All right, now let's look at 4. What's happening to the graph at 4? Got another jump. So on the left side, where does that graph touch that red wall on the left side of the wall? Right here, and what does that equal? -1. On the right side, I'll be right here. It looks like that's about a half. Looks like it's about halfway. Does everyone agree? So I would say about a half. 0.5. Point something. I'm not picky. If you said 0.7, then that's good enough too. Something in between 0 and 1. All right, what about the limit at 4? Remember, if they don't touch each other on the left and right, that means that we don't have a limit at that place. And what would be your answer for the last one? So, wait, which one is closed? Hold on, let me see. Take a 0. Oh, I see it. My line was blocking it. I'm sorry. Let me erase that. So for J, the answer is 0. My line was so thick that I couldn't tell. Sorry about that. So the answer is 0. So then the answer for L is also 0. All right. Who missed less than 5? Okay. That's good. If you miss less than 5, we are on target. All right. Bonus. Is it continuous at x equals 1? So at x equals 1, is it continuous right here? No. What kind of discontinuity do you see at 1? Jump. All right, I'm going to give you one more. This is an in-class assignment because, again, our next test, I did grade the last test. Those are in Skyward. I'm going to give you an in-class assignment, and I just want you to work on it. It's just looking at a graph and figuring out the limits. So I'm about to pass that out. Can I get somebody to pass that out?